I'm currently a student. I work in biology and ecology, but I took with 5 other students a break from our study to carry out our own expedition to Antarctica. So Antarctic 2 Degrés is an interdisciplinary scientific expedition combining research, education, and scientific mediation. So it is an interdisciplinary research connecting 6 research topics. So the global goal of our expedition was to study the impact of humans on the austral and Atlantic ecosystems. So each of us were studying a research topic. So there were climatology, biogeochemistry, microbiology, microplastic chemistry, sociology of science, and my own project, Penguins Ecology. So I will introduce very quickly all this project, and after we will focus on my own research project. So just to have an overview of this mission, it was a sailing expedition, so we left we left from Marseille, which is a French city not far away from Montpellier. And we crossed the Atlantic Ocean by sailing to arrive in Ushuaia, where we took a short break. And after we crossed the Drake Passage, which is known to be one of the most difficult seas in the world. And we did it. And we arrived in the Antarctic Peninsula to continue our project. So, during the Atlantic crossing, we start the first part of the research project. You can, yeah, thanks. It was first studying microbiological diversity in the ocean. So quantifying and analyze the diversity of microbes. It was linked with the biogeochemistry of iron project, because iron in the ocean is a key resource for the life. So they were working together to understand how is the biodiversity according to the concentration of iron. There was the microplastic pollution project. So basically, you put your microplastic net into the sea, and it allows to collect and concentrate microparticles of microplastic in a very, very small volume of water. And there was also another project that we don't really understand when we are not in this kind of research field. It was the ethnography of the expedition. So Margot was studying the way how scientific study in this kind of environment and how they have to adapt their protocols according to the condition of the environment. Okay, so after this part, we start another step of the project in the Antarctic Peninsula. So yeah, Clément and Baptiste continue their project on microbiological diversity and on iron. And Margot continue her own project of the ethnography of the expedition, but she started another project on a scientific base. So maybe you know that in Antarctica there are some scientific base where scientists stay along the year to study and to continue the project along the winter and the summer. So we dropped her on the Vernadsky station, which is an Ukrainian scientific base. So it was just before the start of the war. So it was really interesting for her because she just had the occasion to study scientific and researchers in these kind of conditions. We dropped also Niels on the base because he was studying the atmospheric rivers. So atmospheric rivers are some warm and humid atmospheric air currents around the world, and when they precipitate in Antarctica, it can have a strong impact on the snow cover. And for Olivier, he continues his project, but this time it was on sediments and on fresh snow, because you might know that microparticles of microplastic are also in the air, and when there are some snow, the snow just trap the microparticles, and we can find it in the snow. Okay, so for my part, I'm here to talk about the project of mapping penguins. So I'm working with 3 scientific labs. So the CNRS at Strasbourg, the Woods Hole Oceanographic Institutions in the US, and the Monaco Scientific Center in Monaco. But I work also with 3 French companies, so of course YellowScan, and Teria and Stadron. So for my part, I work on the nesting sites of penguins in Antarctica, because maybe you know that penguins are used by scientific as a biosentinel, because penguins rely on marine ecosystems, but also in terrestrial ecosystems. So if one of the both ecosystems change, it can have a strong impact on penguins. For my part, I focus only on terrestrial ecosystems. It's where the penguin breeds and nest. And this terrestrial ecosystem can change with time because of the impact of global warming. As an example, we can think about the sea level rise, which can lead to an elevation of the sea and a loss of the space. But we can also think about the glacial retreat, so that can free some space. So it's my project to understand how global warming will impact nesting sites and how these modifications can impact the relationships between penguins, because sometimes there are several species of penguins living in the same colonies. Well, so to understand how penguins use their habitat, I first focus on the interspecific distribution of penguins, so how the different species segregate on the field. So for this, I study 3 species of penguins, so the Adelie penguins, the Gentoo penguins, and the chinstrap penguins. So it's not the penguins we are thinking of when we talk about penguins. We all think at the emperor penguins, more like this. But this one are more like this, and they are doing some nests to breed. And I managed to study 11 colonies by sailing, thanks to the boat. And I also carry out spatial analysis to understand how penguins use their habitat according to the characteristic of the habitat, like slope, elevation, orientation, etc., etc. Merci. So for that, I use the mapper of YellowScan, but also all the software lent by YellowScan, so the postpack license and the cloud station license. I also use the matrix of DJI, lent by Ansadron, and also a Phantom 4 Pro because it was a backup, just in case. And the georeferencing systems and the post-treatment license from Terria. So yeah, this is a part of the Antarctic Peninsula. So we sail from a colony to another, just along the peninsula. So each time on the field, I had to find a good way, a good place to land off, because I had to be the more possible far away from the penguins colony to avoid the disturbance. So I managed to have some DEM, and after in the lab I can do the colorization of the point cloud, and also thanks to the camera module do an orthomosaic, which is really useful. I will talk about it later. Yeah, okay. So yeah, the orthomosaic is useful to identify the species and tag the different penguins on the colony. So as an example here in blue it is Gen 2 penguins, and in red it is Adelie penguins. It's only the nesting penguins, and after this I can generate the nesting areas by doing a buffer around the penguins. So this is for the orthomosaic part, thanks to the camera module of YellowScan. And for the DEM part, it is to analyze the different characteristics of the ground. So as I told you, slope, elevation, orientation, but also the distance to the sea, for example. Okay. So when I have this kind of orthomosaic, I have to focus only on the potential usable area. So the snow is not a potential usable area because they can't build a nest onto the snow. So even when I look at the potential nesting area, we can see that they can't nest everywhere. So this is really what I want to understand, comparing the potential unused nesting area and the effectively used nesting area. And by comparing slope, elevation, orientation of these two kinds of areas, I will understand how they choose their nesting sites. There is also a project to compare Adelie and Gen 2 species, because it seems that they don't use exactly the same nesting sites. So we will try to understand what are the differences of their use areas. Yeah, thanks. So to carry out this expedition, we had a very large and wide networks of actors and partners. So public institutions, because I told you at the beginning that it is also an education and scientific mediation project. But we work also with company and foundations. That's why I'm here today. And associations, citizen groups, scientific labs, of course, because we are all researchers, and educational institutions, because we are still students too, so we have to deal with our institution to live away and go to Antarctica. So it was not so easy to do. Voilà, that's all for me. Thank you very much for your attention.